Good morning, mathematicians. Welcome to At Home with APS. I'm Miss Obenchain. This morning we're going to be doing some counting, and we're going to do some counting called choral counting. And choral means that you're going to be counting with me. We're going to try to stay together and count together, almost like it was a chorus, or we were doing it chorally together. So I'm going to be recording our count today as we go, and so you're going to want to try to stay with my pen as we're counting. And then when we're done counting, we're going to be looking for patterns in the numbers. And so today we'll be counting by 20s and then seeing what numbers we can fill in. So the first number we're going to have up on our chart is 0. The next number is 20. And I just want you to just take a minute and think about what would be the next two numbers in our sequence. So if we go 0, 20, and we're counting by 20s, what would be next? I'm going to move this down, and we'll do it right here. So 0, 20, 40, stay with my pen, 60, 80, what am I going to put up here, do you think? What would be 20 more? Just stop and think about that for a minute. You're right, 100. 100. Count with me. 120. 140. 160. 180. And up here we'll have, you guessed it, 200, 220, 240, 260, 280, 300. Oh, I'm running out here. 320. 340. I'm going to stop right there for a minute, and we're going to do some things thinking about some of these patterns. So look at those numbers and see what patterns do you see in those numbers. Do you see any patterns like in the way the tens are changing or what's happening in the hundreds place? Oh, the first pattern that I hear you talking about is this right here. What do we see? 2, 4, 6, 8. Do you see that pattern anywhere else? Oh, we can even add 0 to that, right? So we've got it again here. 0, 2, 4, 6, 8. I think maybe I should have 2 zeros here, because it would probably be this first 0 that we would be seeing it with. 0, 2, 4, 6, 8. 0, 2, 4. I'm thinking about this number back down here. Can we use that pattern to help us figure out what that one is going to be? What do you think it's going to be? All of these have an 8 in that spot right there, right? What other patterns? Let's see if we can figure out what the first number would be. On this one, I'm going to use a different color so it'll stand out differently. We have 1s in every one of these first spots, the 100th spot, right? We have 2s then, so it's changing to a 2. And then these all start with a 3. So you're right, I'm sure you figured it out by now. This would probably be 380, right? Because we have all 3s here, and we have all 80s in that other spot. Let's count and see. So let's start up here together with 300. 300, 320, 340. This one would be 360. And this one will be 380, which is what we were thinking. What do you think this one over here, if I had more paper over here and I could start another row of these, what would that one be? Let's think about it. One way, do you see another pattern that would help us to see that? What other pattern is happening with the numbers? I need another color, other pocket. What's happening going from this column to this column? What do you think? That's right, it's changing by 100, isn't it? This column to get this column, 100. This column to this column is 100. So the top number of our next column is probably going to be 400 because this is 300 and one more 100 would be 400. Plus we have this pattern of all ones, all twos, all threes. So this row is going to start with all fours, you're right. And then we get a repeat of this pattern as well. So there are lots of patterns that we can see in numbers. And so you can figure things out about numbers by looking at the patterns that are there. We used patterns to figure out on our hundreds chart. Last week, we were talking about the 100s and the 200s chart, and we were counting by tens down our rows on the hundreds chart. When we go this way, then we're counting by ones. We talked about that. And so then we could figure out, using those patterns, what we have here. And I'm not going to use orange because it doesn't show up very well, I don't think. I have 176 here. So last week, our hundreds chart puzzles were all kind of in this 1 to 100 range. And this week, I made some that are using the bottom half of our chart. So if we have 176, we're going this way. We're counting by ones on a hundreds chart, so we could try counting backwards. 176, what would be here? 175, right? This would be 6, 5, so this would be 174, exactly. When we're coming up and down, we're counting by tens, right? So 176, then this would be 186. 196, exactly. And then we could count backwards by tens here, right? 196, 186, 176, 166, 156. And then we'd go by ones to get these. Or we could count by tens going this way too, I guess. 175. So this is going to be the 60 row, 165. And that works this way also, doesn't it? 166, 165, 164, and so on. So 186, 185. Exactly. So we can use those patterns counting by ones and tens on the hundreds chart. What about this one over here? 134. What's before 134 if we're going backwards by tens? 124. 114, exactly. But now we would have to count by ones going forward, right? 124, what's next? 125, exactly. 126. 127. And then down here, we're back in that 30s row, even though we don't have these two boxes, right? 137. If we did have those, 134, 136, 134, 135, 136, 137. It would work, wouldn't it? We'll do one more puzzle, and then I'll leave this one, and maybe you can copy this one down, and you could try this one on your own. But what about this one? All the way as if the 200 was in the corner, the bottom of our 200s chart. Going back from 200 by tens is 190. This would be 189. You're right, because we have to go back by ones. This is sometimes tricky, right? Going backwards from a tens decade number here, they always 89, 79, 69, and then you go to the next one. So this one would be 179, and we go back in our puzzle piece, 178. It's like stair-stepping backwards, isn't it? 168, 167, 157, exactly. So So maybe this one you can go ahead and try on your own, or you can look. Last week we posted some on our website that you could pull down, and you could create your own puzzles too on the Hunter's chart. Okay, I think we're ready for Miss Gaudette to come out and work on another type of problem with you. Get this chart out of her way.
Hello, everyone. So we are going to be moving back into problem solving now. So again, just a reminder, take this time to pause me really fast, grab a pencil and paper, or else download the actual task off of the website so that you have that and you can do your work. Again, I'm going to do what I call teacher talk, and it's how I am thinking through the problem. So you need to attempt the problem before you have me go through and how I thought about the problem. All right, let's get started. So our first thing we're doing is called boxing the pots. At the garden center, Mr. Garcia is putting plant pots into boxes, ready to take to the market. The diameter of each plant pot is 3 inches. Each box measures 9 inches by 15 inches. So let's stop there. Let's think about what information do we have, or if we have any information that is relevant to what we need. All right, so let's go ahead and let's look. Do we need to know Mr. Garcia is putting the box and putting the plant pots in boxes? But it's not a quantity and it's not a question yet, so we're going to hold off on that. The diameter of each plant pot is 3 inches. Is that some important information? Yeah. First off, do you know what a diameter is? So I'm going to underline that because that is important information for us. This may be a new term, but it's just enough information that you're going to need to be able to solve. So the diameter, if you're looking at a circle, it is from one end to the other end through the center. So it's the length of how wide it is. So this one is 3 inches. That is information we're going to need to know. So it's a quantity. I'm going to circle it. All right, let's look at the next piece. Each box measures 9 inches by 15 inches. And then they have a diagram for us. Is this important information? Yeah, right? We have the quantity 9 and then the quantity 15. And then they have given us one important information for us before we move on. Do you know what that is? Right? It's this pot right here. They're showing us that there's this pot in here, somewhere in here, and I got to put in more pots in here. Okay, so let's hold off on that. Let's move to the questions. Number 1, how many pots can Mr. Garcia arrange along the side of the box that measures 15 inches? What quantities do we have? We have 15 inches. Do we have any other quantities? No. Do we have a question that we are to answer here? Right? How many pots? But if it's just how many pots, do we need to know any other information? Are we done? Yeah, we need to know a range along the side that measures 15 inches. So that is information we do need to know. So let's go ahead and attempt that before we look at the rest. So I am going to draw the box that we were originally given because that will help us in what we need to do. Now you, if you have downloaded this, you already have this. But you, if you don't have this, go ahead and draw it yourself because it's good information to have. All right. What information do we have that would help us here? Well, I know that each pot is 3 inches in diameter. So I'm going to put that there. I also know I need to get to 15. And if I have 3 inches here, how many more would I need? Well, let's try another one. There's 3 more inches. Yeah, I got to try another one. 3 more inches. How many do we have so far? 3, 6, 9. Okay. Let's get another one in there to get 12, and then one more to get 15. So when I'm doing this, I think I go ahead and show my work. I'm one of those ones who likes to show so that there is no question of what my thought was as we're going through this. And then I'm going to show my math. 3 plus 3 plus 3 plus 3 plus 3 equals the 15 inches. Or, did anybody notice something else? Right? I had 3 inches, and I needed to get to 15 inches. What could I have multiplied 3 by to get 15? Well, I have 1, 2, 3, 4, 5. So that is 5. And my question was, how many pots did I need to arrange? So my answer is 5 pots. And I am going to go ahead and circle that because I want to make sure that someone knows what my answer to that one question is. So let's go ahead and look at number 2. Now we have, how many pots can Mr. Garcia arrange along the side of the box that measures 9 inches? So we're going ahead and let's get our quantities again. So what quantity do we have? 9, thank you. So I'm going to go ahead and circle that. And then what question are we being asked? How many pots? Thank you. I appreciate the input. Arranged along the side that measures 9 inches. Yeah, it's not just 1 or 2 words that we have to figure out. We have a lot of information here that we got to work with. Okay, so I'm going to go back to my original drawing, and I got to get 9 inches. So you know what? I'm going to make life a little easy on myself, and I'm going to go ahead and draw it again. So I know I have 3, so I'm going to draw my diameter going down so that I use that to help me. All right, so now I had 3, 6. So how many, before I go anywhere else, how many do you think it's going to be? Did you get 3? So let's see. Again, I like to draw it. So there's no question for anybody looking at my work of where I was. So I had the 1, 2, 3. I want to show my math to prove that that equals 9 inches. 3 plus 3 plus 3. Or did you see that I had 3 times the 3 pots, the 3 inches, times the 3 pots equals 9 inches. I'm done. Did you get it? Did you see my error? I didn't answer the question. What was the question asking me to do? How many pots, right? So telling you that it's 3, 3, 3, 3, 3, 3 equals 9, yeah, you got to have the pots. So it's the 1, 2, 3 pots. All right, so let's go on to question number 3. How many pots will the box hold? Show how you figured that out. All right, do we have any quantities here? No, but what do I have? I have a question. How many pots will the box hold? And then show how you got it. So let's look at that. I know that it's 5 pots going across, 3 pots going down. I could do it one way where I could show and color in the pots. Some of you might have said, I've already figured it out. I could use multiplication. Perfect. Some of you may be saying, I could use repeated addition. Perfect. Go ahead and solve yours as I'm doing mine if you haven't already done so. So I'm going to add in mine because I know that it goes 3 going down each way. So I know that I have my 5 going across and my 3 going down, and I know I'm going to do the same here. Or as this, I have 5 plus 5 plus 5 equals 15 pots. Or I could have just done the 5 times 3 equals 15 pots. So my question is for you, is have we answered the question? How many pots does a box hold? 15 pots. Did I show how you figured that out? Either one would have been fine. So we did do that. All right. So we are going to move into the next question. Mr. Garcia has 12 pots that are 4 in, hold on. Let me go ahead and move this really fast. All right, so here we go. Mr. Garcia has 12 pots that are 4 inches in diameter. Oh, they're switching some stuff up on us. They can fit exactly into a different box. Our question for us is, what do you think the measurements of the box length width? What do you think the measurements of the box will be? And what is the length? What is the width? And explain how you figured it out. So again, we go into what quantities do we have? So we know that we have 12 pots, right? We know the diameter, again, the diameter is from starting in the, going through the center, a line that goes from one edge to the other edge. So we know we have 4 inches in the diameter. And then what else do we need to know? Our question. What do you think the measurements of the box will be? So what are the measurements of the box? What is the length, width, and then explain, right? So if we were to start thinking about this, we know we have 4 inches. One of these is 4 inches. And we know we have 12 pots. That's important information. I'm already told how many pots. And if we know that there's 12 and we have 4 inches, I could probably go ahead and say, all right, well, here's 4 inches. Well, then what would I have to also do? Well, I could say 1, and then I could go up and just start filling it in. 2, 3. Am I done? Have I figured it out? No. So let's keep going. We have 1, 2, 3. We have to do, let's do 4 pots. Maybe I could fit another pot in here. I don't know. Let's see. I only have 12. And if I put another pot here on the 5 and made that 5 pots, could I get to 12 with it fitting in there evenly without gaps? All right, so I'm going to go ahead and leave you with that. We'll come back with this on Thursday to think about if you solved that and how you figured it out, and then look about how I figured it out. So we're going to move on to I always say her last name, Carness, and she will be working with you on a read aloud.
Great. Good morning and good day, mathematicians. I'm so glad to be here to share another story with you today. So let's get started. Today's story is called Two of Everything, and it was written by Lily Toy Hong and published by the Albert Whitman Company from Chicago. This is a story about a husband and a wife who find a magical pot that doubles everything they put inside it. Let's go ahead and read. Once long ago, in a humble little hut, lived Mr. Hacktack and his wife, Mrs. Hacktack. They were old and very poor. What little they ate came from their tiny garden. In a lucky year, when the harvest was plentiful, Mr. Hacktack had a little extra to take to the village. There, he traded turnips, potatoes, and other vegetables for clothes, fresh seeds, and other things they needed. One spring morning, when Mr. Hacktack was digging in his garden, his shovel hit something hard. Confused, he dug deeper into the soil until he came upon a giant pot made of brass. "How odd," said Mr. Hacktack to himself, "to think that I've been digging here all these years and never found this pot before. I'll take it home. Maybe Miss Hacktack can find a use for it." The pot was big and heavy for old Mr. Hacktack. As he stumbled along, his purse, which held his last 5 coins, fell to the ground. He threw it in the pot for safekeeping and kept walking home. His wife met him at the door. "Dear husband, what a strange pot." Mr. Hacktack explained how he found the pot. "I wonder what we can do with it," said his wife. "It seems too large to cook in and too small to bathe in." As Mrs. Hacktack leaned over to look into the pot, her hairpin, the only one she owned, fell into the pot. She felt around inside, and suddenly her eyes grew wide with surprise. "Look," she shouted, "I've pulled out 2 hairpins exactly alike and 2 purses." Sure enough, the purses were identical, and so were the hairpins. And even better, inside each purse were 5 gold coins. So now they have twice as many hairpins and twice as many gold coins, right? Mr. Hacktack was so excited he jumped up and down. "Let's put my winter coat inside the pot. Then, if we are lucky, the pot will make 2 coats and we can both stay warm." So into the pot went 1 coat, and out of the pot came, you guessed it, 2 coats. They quickly began to search the house and put more things into the magical pot. "If only we had some meat," said Mr. Hacktack, "or fresh fruit, or even one delicious cake." Mrs. Hacktack smiled. "I know how we can get anything we want," she said. "What do you think Miss Hacktack has planned?" Let's see. She put their 10 coins into 1 purse and threw it into the pot. What a great idea. She pulled out 2 purses with 10 coins in each. Now they have 20 coins. "What a clever wife I have," said Mr. Hacktack. "Each time we do this, we will have twice as much money as we did before." The Hacktacks worked late into the night, filling and emptying the pot until their floor was covered with coins. Morning came, and off went Mr. Hacktack with a long list of things to buy in the village. Instead of vegetables to trade, his basket was full of gold coins today. Mrs. Hacktack finished all her chores and sat down to have a cup of tea. She sipped her tea and admired the brass pot. Then, with a grateful heart, she knelt down and hugged the pot. "Dear pot, I do not know where you came from, but you are my best friend." She stooped over the pot to look inside. Just then, Mr. Hacktack returned. His arms were so full of packages that he kicked the door open with his foot. Bang! Mrs. Hacktack was so startled that she lost her balance and she fell into the pot. Uh-oh. I bet you can guess what happens next. Mr. Hacktack ran over and grabbed his wife's legs. He pulled and tugged until she slid out onto the floor. But when he looked at the pot again, he gasped. 2 more legs were sticking out of the pot. Naturally, he took hold of the ankles and pulled. Out came a second person who looked exactly like his wife. The new Mrs. Hacktack sat on the floor looking confused. But the first Mrs. Hacktack cried, "I am your one and only wife. Put that woman back into the pot right now." Mr. Hacktack yelled, "No, I will not put her back. If I do, we will have not 2 women, but 3, and 1 wife is enough for me." He backed away from his angry wife, tripped, and he fell into the pot. Both the Hacktacks rushed to rescue him. Each grasped an ankle, and together they pulled him out. There were 2 more legs in the pot, so they pulled out the second Mr. Hacktack too. "Just what use does one Mr. Hacktack have for another?" Mr. Hacktack said angrily. "This pot is not as wonderful as we thought it to be. Now even our troubles are beginning to double." But Mrs. Hacktack had been thinking. "Calm down," she said. "It is good that the other Mrs. Hacktack has her own Mr. Hacktack. Perhaps we will become best friends. After all, we're so alike. He will be like a brother to you, and she a sister to me. With our pot, we can make 2 of everything, so there will be plenty for all." And that is exactly what they did. The Hacktacks built 2 fine homes, each with identical teapots, rice bowls, and furniture. From outside, the houses looked exactly the same, but one was different. Inside one house was hidden a big brass pot. Of course, the Hacktacks were very careful not to fall into it again. The new Hacktacks and the old Hacktacks did become good friends. The neighbors thought the Hacktacks had grown so rich they decided to have 2 of everything, even themselves. What a wonderful pot! A pot that doubles everything. I wonder what you might put in that pot if you had it. We're going to take a look at some of the math that goes along with this book. And we're going to use a tool called a bead rack to help us think about some of the doubling. So if we had a pot, a doubling pot, and we put 1 thing into the pot, how many things would come out of the pot? 2, right? 2 is the double of 1. So now, if we put those 2 things back in the pot, how many would come out? You guessed it, 4, the double of 2. Now, if we put 4 things back in the pot, we're going to end up with even more, aren't we? So 4 more. Now, whatever we threw in the pot, we have 8 of. Oh. And now, if we throw those 8 things back in, let's see, we can show this on the rack, right? 3 and 1 and 3 and 1 is going to give me 4 and 4 more. And can you tell how many altogether now I have? Doubling that 8, I have 16. 10 and 10 and 3 and 3, or double 8s. Now, we can't double any higher on the bead rack, right? So let's do the rest together here. Right? So these are the problems we've already doubled. 1 plus 1 for 2. 2 plus 2 plus 2 for 4. Maybe I need a tape here. 4 plus 4 for 8. And one more. 8 plus 8 for 16. We'll tape that up in just a second. So let's think about now the next number to double, right, would be 16. How might we think about doing that? So you might think to the bead rack that we used and how nicely you can see tens, right? So maybe you thought about 16 plus 16 and then putting your tens together to get 20 and your sixes together to get 12. And 20 plus 12 is going to give us 32. So that's our next double. You might have also thought about an easy double to use, like maybe you knew 15 plus 15 equals 30. So then you knew that 16 plus 16 would be 2 more, 32. Those are a couple of ways to think about it. All right. Or even one more way might be to think about 16, make a big jump of 10, would get us to 26, plus a smaller jump of 4 gets us to 30, and just 2 more gets us to 32. These are all some ways you might have thought about doubling 16, our next double in the story. But I have a question for you now. Do you think that by starting with throwing one thing in the pot and following this doubling pattern, would we make it ever to exactly 100? Well, what's our next double? Our next double is going to be 32 plus 32. And that's a pretty easy one to put together, right? So 32 plus 32, 64, right? So if 64 is our next double, and then we double 64 again, is that going to get us to exactly 100? No. It's going to put us over 100. And so starting with one item in the pot and doubling won't get us to 100. But I wonder if there are some other ways that we could get to 100. So let's just talk a little bit about how you might think about this at home. Okay. That's something to think about. Here is our list of doubling equations. Oh, we lost one. We always lose one, huh? All right. So, my questions for you to think about at home are, what equations might we get if we started by throwing 3 things in the pot instead of 1? Also, experiment with this question that I had already asked you. Is there a way to get exactly 100 from the doubling pot? Is there more than one way to get exactly 100 from the doubling pot? How many ways could we reach 1,000 using this doubling pattern? Try problems like these, investigations with doubling, with other numbers too, and I'd be interested to hear about your results. Also, think about a doubling pot. What if you had one? What would you throw in? Thanks, guys, for enjoying another story with me today. And we're going to be passing it over to Mrs. Sears, and I think she's going to let me play a game with her.
I have a couple of games that I'm going to be playing with you, so that should be quite interesting. I'll put that over there for you.
Thank you, ma'am.
Okay. So the first one we've played before. Hi, I'm Mrs. Sears, and welcome, mathematicians. We have played this game before, and maybe you have seen it before. It is called Headbands. So the object of this game is that I'm going to be wearing a headband, which describes a mathematical term. Miss Cardis is going to have to describe that mathematical term without telling me the name of it, but I have to guess what it is. And the object of it is that hopefully we can do these set of words, which will relate to a particular concept. Hopefully we'll have some idea of those mathematical terms that go with those specific concepts. But we have to do this in under a minute. So we have 4 mathematical terms. They're going to be related in some way to a mathematical concept. And you have to describe them. I cannot see them. You have to describe them so that I am able to say the word. Okay? So what I'm going to first do is when I put the first headband on my head, I'm going to show you guys, and then I'm going to turn to Miss Carney so she can describe it to me. Okay? So I'll stand there for a second so that you can pause and read the word, but I won't know the word, so don't tell me what the word is, okay? All right, here we go. Here's our first word.
Okay.
Oh, I don't know if I showed it to you guys enough. This feels long.
All right. It is a long word.
Okay.
It is a word that has to do with measurement, right? It's a measurement word.
Okay, measurement. I think I know a little bit about that.
And this measurement word is related to the sides of a shape and how far or the length around the outside of a shape.
Around, that's perimeter. I know around is perimeter. Am I right?
Ding, 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 ding.
Okay.
She is right.
All right, here we go. Next word.
Okay, so another measurement word, right? This is a word that we use when we talk about measuring how tall something is, or maybe the distance from one place to another.
Length? How tall?
She right? How tall?
Length?
And distance?
Okay.
Ding, 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 ding.
All right, I don't know if we've been like over our minute here, but let's see.
Okay.
What's this one?
All right, another measurement word. It's sort of the other piece that goes with length. So length is how tall, or maybe the distance between. This word has to do with how wide something is.
Oh, I don't know if you're going to give me that word. I think it's width, but can you say wide?
Do you think I could say wide? I guess it's too late because I already did. But Mrs. Sears guessed it. Okay,
all right.
last
Sorry,
one.
I didn't show you.
Last measurement word. So this word is another type of measurement that is sort of a complement to perimeter. Perimeter measures the length around a shape.
Okay.
This is about how much space is inside a two-dimensional shape.
Area. We were talking about this with the pot problem. Yeah, that would work just
Ding,
fine.
ding, ding, ding.
All right, cool.
Good job remembering our
Hey.
terms.
Air high five.
Okay, now it's my turn.
It's my turn, and I'm going to have to describe these words. I'll have to look really quick to see what those might be, but
okay. Tell me if they're upside down.
I don't know. I'll have to tell you if they're upside down.
Okay.
Okay, so she's going to show you the word.
Is it right side up?
Those are right side up,
Okay.
yes. So these words are going to have to do with the idea of multiplication. So a concept of multiplication. All right, so the answer to a multiplication problem is going to be the...
Oh, gosh.
This is when a factor times a factor equals a...
Oh, I want to say sum, but I know it's not sum.
Sometimes you can go to the grocery store and buy these things, but they're not mathematically related.
It's a product.
Yes, there you go.
A product is also the answer to a multiplication problem.
All right, let's see.
Here we go.
Hopefully they're straight up there. Okay, so this word is inside of that long concept word that we were talking about, but it has to do with, like, if I'm skip counting by a particular number, I would have blank of these numbers. So like 2, 4, 6, 8, 10, 12 are all
So those are all numbers I could get by multiplying 2, and that makes me think that the term is called multiple.
Multiple is right. Ding, 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 ding. Okay, we've got to go through these quicker than we're going through, I think.
Is this? Nope.
Nope, that's upside down.
Better?
All right, so this earlier I talked about the product being the answer. This would be a number times another number, which are the They could also be multiples of those numbers, but their numbers times a number times another number would both be these numbers, but they equal a product.
Oh, the numbers that make the product are its factors.
Yes. All right.
Do we have time for the last one?
I think we have time for one more, but I think we went over our minute and tried to describe it. It's right side up. Okay, so again, thinking in multiplication, this is a way to represent multiplication, where we put the items in rows and columns. And so in the rows, that would tell us one of the factors, and then in the column, or in each, these would also represent what it was with the multiplication sentence.
It's an array. We've been using arrays a lot in these lessons.
And I do remember seeing an array on that pot lesson too that Miss Gaudette did with us earlier today.
Thank you, Mrs. Sears, for helping us review our vocabulary.
So that was a little game that you can kind of review and do with your vocabulary. So if you guys want to make up some terms, some related terms, you could do that at home too. But I do want to get to our game today, because I always love playing a game with my friends, with my other mathematicians. And today this game is called Subtraction War. All right, so let me explain to you how this subtraction war works, because maybe you've played addition war, maybe you've even played multiplication war. But subtraction war is just a little bit different. All right, so we have a deck of cards. I've already gone ahead and shuffled this deck of cards, and I've split them exactly in half. So Miss Carnes has half, I have half, and what we're gonna do is we're gonna be pulling 2 cards, okay? So when I pull these 2 cards, let's say I had a 5 and a 4. I'm gonna have to figure out how I'm going to subtract those 2 numbers so that I have a difference. So when I'm subtracting the 5, and the 4, I'm thinking, well, I probably want to have the bigger number before. So 5, I would do first, 5 minus 4. That would give me a difference of 1. So with the difference of 1, that would have to be greater than whatever the difference of the 2 cards that you pulled. If she pulled a 7,
likely.
Yeah, if she pulled a 7 and a 5, so a 7 and a 5, so 7 minus 5, because again, we want to put that bigger number first, that's only going to give us a 2. She would actually win that round because she did have a bigger difference than I did. Let's say, though, she had a 7 minus 6, and we both got a 1 for our difference. It's a war, okay? When there's a war, we have to then deal 4 more cards out, or take 4 cards out that we can't even see. We're going to pull 2 more cards. This time, this is the tricky one. We have to do an addition sentence, okay? So in that case, we have to do 2 cards. We have to quickly add them up, and whoever has the greater sum is going to be the one that wins. So a little bit different than how you might have played, but the person who has the greater sum is going to collect all of those cards. And you're right, the one that's going to be the winner at the end is going to be the one that has the most cards. Are you guys ready to play Subtraction War?
I'm ready.
To battle? Okay.
I'm ready.
This is always my favorite thing to do. I like playing games.
Okay.
All right, so our 2 cards. Oh, and I forgot to tell you that face cards are worth 10.
Okay.
Aces are worth 1. Okay, so in this instance, I got a 10 because I have a face card, and a 2.
I also got a face card, so that equals a 10 and a 5.
Okay, let's see. Remember, the one with the greater difference is the one that wins. So I have 10. I'll maybe make that go in that way. 10 minus 2, so that's going to be 10, 9, 8, if I counted down to that number.
That's a good way to do it.
All right, so 10 minus 2 would be an 8. So I have a difference of 8.
All right, and I have 10 minus 5, and I know my doubles, so I know 10 minus 5 is 5, because 5 plus 5 is 10, and rats.
Yes, I get those
Sears
cards.
Wins that
Throw them
round.
over here. I'll take them. I'll take them. All right, ready for another one? Let's see. This time I have a 7 and a 5.
Ooh. Well, guess what? Mrs. Sears is for sure going to win. I already know because I have a 4 and a 4. And if you take 4 away from 4,
that's all you got.
Nothing left.
Okay. Well, I have 7 minus 5, so I'm going to have 2. So I'm going to have a bigger difference on that one.
She wins again.
All right. So 2 for me. All right. Here we go. Ready? 6 and a 5.
Okay, and I have a face card again, so that counts for me as a 10 and a 9. Oh,
Ooh, that's a real close number, but yeah, let's see.
and
I think we have a war.
we have a war.
I
Oh
have
my gosh.
6 minus 5. That's only a 1.
And a 10 minus 9 is a 1.
All
so
right,
let's
4
battle.
cards.
Let's battle.
Okay, let's put them down. 4, and then you have to pull 2. And now, which the operation we're using? It's addition, right?
Addition this time.
Okay, so I have a face card, a queen, and a 3. So I've got to add those numbers together. That's 13.
Oh man, I have a face card also, a queen worth 10. And I have another 10. Woo! 20 is my answer. So finally, I win this round.
So she's going to get a lot of cards. Darn. Yes. She might be ahead of me now. I have to win a few more rounds. Okay, are you ready?
Those are mine. I'm ready. I'm ready.
Okay, this time I have a 10 and I have a 5.
Oh, okay. And we're back to subtraction now, right?
Yeah, we're back to subtraction.
Okay.
So 10 minus 5, I know those doubles.
So
5 plus
I
5
have a
is
10
5.
and a 3. So 10 take away 3 is going to leave me with 7.
How did you get down to that? Did you do a countdown too?
Well, I just kind of knew like my numbers that go together to make 10, but if I didn't know, I could have counted back 10, 9, 8, 7 and got the answer that way.
So you still got that one too. You're coming ahead of me now.
I'm on a roll. I'm on a roll.
I'm telling you. Okay, here's my next one. I have 8 and a 6. I'm going to put that 8 because that's the bigger number. So 8 minus 6, that's going to be 2, right?
Right. And I have a 10 and a 2. So I know 10 minus 2 is going to give me 8 because it's only one different than the last one, right? Which was 10 minus 3 was 7. So 10 minus 2 is 8.
Okay, you got that one too.
I won that one. It's my lucky day.
Oh, I got 4 cards, man. Woo, I only won those first 2. You've got tons of cards over there.
I don't even know how many I have.
I have a 10 and an 8.
What's your difference?
Oh, it's 2.
How'd you get it?
I just did 10, 9, 8.
Counted back?
I could have gone all the way back counting, 8, but I knew I only had to go to 8, so that's where I stopped.
You could have counted up too, right?
I could have.
8, 9, 10.
9, 10, that's a
Not the two
better
that way.
strategy too. So yeah,
good.
my difference is 2.
All right, so I have a face card of a jack worth 10, and then I have a 2. So my problem is 10 minus 2. And again, I know my numbers that go together to make 10. So 10 minus 2 gives me 8.
It's almost like our problem was like a commutative property of each other.
It really was.
Yeah.
Because,
Like if I could put
because 8 and 2
would make this
equals
10.
our 10s.
And either way that you did it, I think that's kind of clever.
That's very cool.
Ah, interesting. Okay. Ooh, I have an ace this time. Remember that ace is worth 1. So I have a queen, which is a 10 minus 1, 9.
All
I
right.
just have to count back 1, 10, 9.
And I have a 7 minus 3. I'm going to think about my doubles for that again, because 3 plus 3 is 6. So 7 take away 3 must be 4.
Ah,
So
I think I got that one. Finally.
finally, you got one.
Yes, let's see. I think I'm getting very close to you now, but not quite. You won that war. That was the worst one that I could have not gotten, because the war you got 8 cards plus our other 2 on top. So, all right. I know I'm not going to be that good this time. I have a 9 and a 9. So 9 take away 9 is going to be 0.
All right. Well, I have a 7 and a 2. And I know my 5 pluses, so I know that 5 plus 2 is 7, so 7 minus 2 is going to give me 5.
Yep.
So I'll win that one.
All right. So really at this point, because I know we're kind of coming almost to our time that's up, we would be counting our cards. So my cards that I probably have, I'm going to say, just knowing, because this is your stack over here that went with your war.
I just
comparing my stack and knowing that she probably had a slightly bigger stack than I did when that happened. I'm going to say more than likely, I think just given that, she's probably the winner of this particular game. I have to give it to you. You were a tough battle.
Oh, well.
I thought I was off to a good start.
Well, I appreciate you playing with me. It's always very fun, and we got to practice our subtraction facts, which is excellent.
So mathematicians, we just wanted to say goodbye for today, and thank you for joining us with At Home at APS, and hope you have a great day. Thanks.
Bye, guys.